In part 1, we covered the first 12 hours of a fast, the fed state, where insulin runs high and fat burning is locked down. The early fasting state, where glucagon rises and the liver begins drawing on its glycogen reserves. And the 12-hour threshold, where those reserves approach depletion and your body faces a fork in the road, a metabolic decision that defines everything that follows. Today, we're walking through what happens when your body takes that fork. Hours 12 through 24. This is the window where the metabolic switch actually completes, where fat burning becomes the dominant strategy, where ketones begin rising in your bloodstream and crossing into your brain, and where a biological process that earned its discoverer a Nobel Prize in Physiology or medicine quietly begins to activate inside your cells. If you're practicing 16 to 8 intermittent fasting, eating within an 8-hour window and fasting for 16, this is the territory you reach every single day. Understanding what's happening in your body during these hours will fundamentally change how you relate to your practice. And if you're over 50, I want you to pay particular attention to what the research says about how these mechanisms interact with aging, because the science here is not just interesting. It's directly relevant to your health in ways that very few interventions can match. Let's pick up at hour 12. The metabolic switch, hours 12 to 18. Liver glycogen is depleted. Your body can no longer simply break down stored sugar to maintain blood glucose. Gluconeogenesis, the liver's manufacturing process for new glucose from amino acids, glycerol and lactate, has taken over that job. And simultaneously, the dam on your fat stores has broken open. Lipolysis is now running at full speed. Free fatty acids are flooding into the circulation from your adipose tissue. The hormone-sensitive lipase that insulin had been suppressing for hours, the very enzyme responsible for releasing stored fat, is now fully active. Your fat cells are finally doing exactly what they were biologically designed to do, providing fuel during the absence of food. As your liver receives this surge of free fatty acids, it does something remarkable. Instead of burning them all directly, it converts a significant portion of them into ketone bodies through a process called ketogenesis, which takes place in the mitochondria of liver cells. The primary ketone produced is beta-hydroxybutyrate, abbreviated BHB. It's joined in the bloodstream by acetoacetate and small amounts of acetone. These are not the toxic molecules that some people mistakenly associate with the word ketone. Those concerns relate to diabetic ketoacidosis, a very different clinical situation involving extremely high ketone levels in the absence of insulin. What we're describing here is nutritional ketosis, a moderate, controlled rise in blood ketones that is entirely normal, entirely safe, and according to a rapidly growing body of research, actively beneficial. The rise in circulating ketones signals what researchers at Johns Hopkins and elsewhere describe as the metabolic switch, the point at which the body transitions from running primarily on glucose to running primarily on fat-derived fuel. Studies published in the journal Cell Metabolism describe this switch as typically occurring between 12 and 18 hours of fasting for most people. For those with greater metabolic flexibility, people who fast regularly or eat lower carbohydrate diets, it happens earlier. For those with significant insulin resistance or who ate a carbohydrate-heavy last meal, it may happen closer to the 18-hour mark. For those practicing 16 to 8 fasting consistently, reaching this switch every single day is not a trivial achievement. It is the core metabolic event that produces the documented benefits of the protocol. Improved insulin sensitivity, enhanced fat oxidation capacity, better blood sugar control, reduced fasting insulin levels. These outcomes accumulate from the repeated, daily practice of reaching and sustaining the metabolic switch. The New England Journal of Medicine published a landmark review in 2019 stating that eating within a 6-hour period and fasting for 18 hours can trigger this metabolic switch, associated with increased stress resistance, increased longevity, and decreased incidence of diseases, including cancer and obesity. 18 hours. That's the far end of a slightly extended 16 to 8 window. It is not extreme. It is, metabolically speaking, exactly where the research says meaningful transformation deepens. What ketones do to your brain? One of the most significant and underappreciated aspects of the metabolic switch is what happens to your brain when ketones become the primary fuel. The brain is your most energy-demanding organ. It accounts for roughly 20% of your body's total energy expenditure, despite representing only about 2% of your body weight. Normally, it runs almost entirely on glucose, but it was biologically designed to use ketones as an alternative fuel source. And the research on what happens when it does is striking. Ketones cross the blood-brain barrier efficiently through specialized monocarboxylate transporters. Neurons take them up and oxidize them readily. And here is the finding that has particular significance for those of you over 50. Research published in Frontiers in Endocrinology found that ketone uptake in the aging brain is not impaired the way glucose uptake can be. As we age, the brain's ability to metabolize glucose tends to decline, a pattern that researchers have linked to cognitive aging and, in its more pronounced forms, to the early stages of Alzheimer's disease. Ketone uptake, however, remains intact even in aging neural tissue and in early mild cognitive impairment. BHB, beta-hydroxybutyrate, is not merely a fuel molecule. Research published in Annual Review of Nutrition describes it as a signaling metabolite with a variety of functions at both the cell surface and inside cells. It inhibits a class of enzymes called histone deacetylases, which are involved in gene regulation and cellular aging. It suppresses the NLRP3 inflammasome, a key driver of neuroinflammation, through direct molecular interaction. It influences the expression of genes associated with stress resistance and longevity. Your liver produces this molecule during a fast. It travels through your bloodstream. It crosses into your brain, and it tells your neurons, with measurable molecular precision, that the metabolic environment has changed and that certain adaptive responses are now appropriate. Fasting isn't just changing what fuel your body uses. It's changing what signals your cells are receiving. This is why so many people who fast consistently describe a quality of mental clarity in the fasted state that they find difficult to replicate otherwise. Not a stimulant buzz, something quieter, a sustained, even focus that arrives somewhere around the 16 to 20 hour mark and persists as long as ketone levels remain elevated. That experience has a biochemical basis, and now you know what it is. Autophagy, the cellular cleanup that fasting activates. Somewhere between 16 and 24 hours into a fast, a second major biological system begins its activation. This one earned its discoverer, the cell biologist Yoshinori Ohsumi, the 2016 Nobel Prize in Physiology or Medicine. The system is called autophagy. The word comes directly from the Greek, autos, meaning self, and phagion, meaning to eat. Autophagy is the process by which your cells selectively dismantle and recycle their own damaged, dysfunctional, and worn-out components. Every cell in your body contains mitochondria, the organelles that produce the ATP your biology runs on. Over time, some of these mitochondria accumulate damage. They generate excessive reactive oxygen species, harmful byproducts of energy metabolism, in quantities that healthy mitochondria don't produce. They become less efficient. Left unchecked, damaged mitochondria contribute to the chronic, low-grade inflammation that underlies so much age-related disease. Your proteins accumulate misfolding errors. Cellular debris builds up. The internal environment of the cell becomes increasingly disordered. Autophagy is the maintenance system that addresses all of this. During the process, specialized double-membrane structures called autophagosomes form inside the cell, wrapping around damaged mitochondria, misfolded proteins, and dysfunctional cellular components. These autophagosomes then fuse with lysosomes, the cell's chemical recycling centers, which break down everything captured inside them using degradative enzymes. The molecular components that were once damaged junk are liberated and become available again as functional building blocks. This is not metaphorical cellular housekeeping. It is measurable, observable, peer-reviewed cellular biology. And fasting is one of the most powerful known activators of the process. A systematic review in Advances in Nutrition from Tabriz University of Medical Sciences states clearly that intermittent fasting and calorie restriction lead to the induction of adaptive autophagy and increased longevity in cells. A landmark 2025 study published in the Journal of Physiology, measuring autophagic flux directly in 121 humans randomized to 3 groups, found that the intermittent fasting group showed a statistically significant increase in autophagic flux compared to standard care at 6 months. The researchers described their findings as evidence that nutrient restriction can improve a primary hallmark of biological aging. Those words, primary hallmark of biological aging, are the careful language of peer-reviewed science, not marketing. For those over 50, research published in the World Journal of Cardiology in 2024 found that autophagy is reduced in aging cells, and that this reduction is linked to myocardial hypertrophy, atherosclerosis, and cardiac dysfunction. The cellular recycling system your body was biologically designed to deploy is running at lower capacity as you age. Fasting is one of the most effective ways to reactivate it. What the 12 to 24-hour window feels like from the inside. The biochemistry is clear. What about the experience? Around the 12 to 14-hour mark, some people, particularly those new to fasting, feel the metabolic transition. A brief headache, a wave of fatigue, a foggy quality to their thinking. This is the glycogen depletion zone, the body working through its last liver glycogen reserves and ramping up fat oxidation. It is temporary. It is a transition signal, not a distress signal. And with consistent practice, it diminishes, eventually disappears as metabolic flexibility develops. Somewhere around 16 to 18 hours, something shifts for many people. The fog lifts. Hunger, which may have been insistent and cyclical through the earlier hours, softens noticeably. A different quality of mental clarity arrives, not sharp and caffeinated, but sustained and even. This is the ketone effect. Beta-hydroxybutyrate is crossing the blood-brain barrier. Your brain is running on a fuel source it was biologically designed to use, and it turns out to find that fuel genuinely effective. This is the experience that long-term fasters describe when asked why they continue the practice. Not the weight loss, not the blood test results, but the functional clarity of the fasted state. That experience is not placebo. It has a precise biochemical mechanism, and it becomes more accessible and more consistent the longer you practice. Reaching the 24-hour mark takes you into stage 5 territory, where growth hormone surges, autophagy deepens further, and the body begins processes that the research on aging has found to be genuinely extraordinary, which is exactly what we're covering in Part 3, Closing: What's Coming. In Part 3, in this video, we've walked through the metabolic switch, the rise of ketones and what they do to your brain, and the awakening of autophagy, the Nobel Prize winning cellular cleanup program that fasting uniquely activates. These are the processes that make hours 12 through 24 the most metabolically consequential window in the standard fasting day. But there's a third phase of this story, one that goes deeper than most people ever venture. And what the research has found there is genuinely remarkable. In Part 3, we're covering what happens after 24 hours. The surge in growth hormone that protects your muscle tissue. The deepening of autophagy. A 2014 study published in Cell Stem Cell that described something researchers said they never could have predicted. And that has profound implications for aging and immune health. And a direct comparison of what 16 to 8 versus alternate day fasting actually delivers at each stage. If this series is giving you something useful, please hit subscribe right now and turn on notifications. Part 3 is where the deepest biology lives, and you don't want to come in at the end without the foundation this video just gave you. Like this video if it helped you. And leave a comment below. I genuinely read everyone, and your questions shape what we explore next on this channel. Part 3 is coming. I'll see you there.